My lecture on Chapter 5. This is going to be dealing with decisions, specifically ifs, if statements. So this is my little lecture project, and I have a variable of type int. Remember, this is an assignment operator, not a test for equality, so it takes the 10 on the right and sticks to the memory location pointed to by the name on the left, which is x. So if I were to do a test using if, there are couple different ways that you need to know about this. And if you look on page 119, you'll see a syntax statement. The condition goes in here, and the condition returns a logical Boolean value. It's either going to evaluate as true or as false. So if I put x, spot as my x equal 10. Now that's not going to do what you think it's going to do, because in C++, that is not a test for equality. That is an assignment. All right. This statement, the way it's set up right now, will always evaluate as true. And here's why. Under the hood, most compilers have constants, a true constant, a false constant. Now these have numbers associated with them. But as far as the compiler goes, the rules for the compiler, anything that is non-zero is considered true. 12, 1 million, minus 6, those are all true. The only thing that is false, the only number that is false is 0. All right. So since this is not a test for equality, and it should be, then what this is going to do inside this set of parens here is assign 10 to x. Therefore, this will be true because it'll be 10, it won't be 0, and it'll always evaluate as true. That's a logical error. Now, a test for equality in C++ is two equal signs. All right. Now, this would check to see if x does hold the value of 10 in that memory location. And it does. If I change this to 9, then when I hit this if condition, it will say, is x equal to 10? No, it's not. It's equal to 9. So this would evaluate as what? True or false? It evaluates as false because x is not 10. It is 9, so that's false. Now, if I were to do this, going back to our little logical error here. Whoops. What do you think this would evaluate as? Well, since 0 represents false, and we're overriding this 9 here with this assignment operator, 9 gets wiped out, 0 gets put in its place. This is now 0, which is false all the time. So this section of code would always evaluate as 0. And this happens when people forget to put the double assignment or double equal sign in there. Okay, now, there are two different types of ifs, so to speak. There's what's called the single alternative if, right? And the dual alternative if. And that simply means it has a true side and a false side. If this evaluates as true, anything here gets evaluated. If this evaluates as false, well, the else would hit it, because if this is false, it's going to run on the false side. And whatever code I wanted here would actuate or run. Now, if you put one line of code in here, you don't need the curly braces or the code block. You always have to have those opening and closing curly braces. Otherwise, you're going to get some logical errors and some things aren't going to work out right. So if I say x equals 1 here, said x equals 1,000 here, let's just go 1. No end if clause. Now you can put it in there if you want to with a comment like this, if it'll help you with it. But there's a way around that later when we get into nested structures like this. So if x is equal to 0, then I'm assigning the value of 1 to x. Else I'm assigning a value of 100 to x. Now, why would you want to use a dual alternative if instead of a single alternative if? Well, it just depends on what you're doing. If you need to change the value only if something is true here, then you don't need the else statement. But if you have to do something that is false and something different if it's true, or excuse me, something different if it's false, then you would have the dual alternative. Now, If you're going to do a bunch of different things in here, more than one, you need the open braces. And put them in. Ban it anyway. To you. Just don't put it in there if it. And what I see often. Let me fix this here real quick. Say the person wants to have 2 lines of code associated with this if here. And let me declare another variable quickly here. All right. And what you'll see is this. Let's do this plus equals 1. Now it's trying to tell you that this line of code is not associated with this if because there's no curly braces. So what will happen, the programmer will say, oh, okay, or the student will say, if this is true, I want to add 1, I want to assign 1 to x, and I want to add 2 the value of y. Well, since you don't have this associated with the if, you cut the box or curly braces, regardless of whether this is true or not, this is always going to run because it's not associated with this. So as soon as this finishes, it's going to do this regardless, which is not what the programmer in this case was wanting, or the student programmer. That would need to be done like this. That groups it together with that if. See how it pushed it over? So now I've got more than one statement here, so I have to have opening, closing, curly braces. And there you go. If this is true, it will run these 2 statements. Is x equal to 0? No, it's not. X is equal to 9. So this would be false, and there's no else statement, no false side, no dual alternative if, so it just goes down here and continues on. And I've got any instead of int. I bet y'all didn't you? Oh, crud. Apples and Microsoft. Why? All right, so that's your basic if statement. Now let's turn over to page 120. Let's look at logical comparison operators. And all of these can be used in if statements. Figure 5-6, you have less than or equal to, greater than or equal to, and not equal to. Usually you can change the way it's written and get away from using that not equal operation, but typically, there are instances where you have to do it like ASP.NET callback functions for web pages. It uses that exclusively, but you can flip the logic and get away from that. It's just like thinking in terms of a double negative. Now let's jump over to page 121 and notice that they have logical comparisons and mathematical operators in here. And notice they give you precedence numbers in figure 5-6, just like mathematical operators. Here's the thing to remember. Now, you probably need to know these for tests and so forth, but the thing to remember is mathematical operations always have precedence over logical comparison operators. And if you look at this figure 5-7, you will see that that's the case. So they look at the math on the left, look at the math on the right of that less than, greater than, or less than symbol. And as you can see, that happens last. So the mathematics has to be resolved before the logic is resolved. Alrighty, let's flip over to page 127. Let's talk about ands and ors. Okay, ands are 2 ampersands instead of the keyword and. It's 2 ampersands. All right, let's see. So what the rule for an and is a review for you. There's my and. I have condition 1 on the left and condition 2 on the right, and it parses from left to right. So it'll always look over here first. Is x equal to 0? No, it is not. Well, the rule for an and is both condition 1 and condition 2 must be true for this whole thing to evaluate as true. Alrighty. That being the case, there's something called the short circuit operation that's into the compiler. So if the rule is x has to be equal to 0 and y has to be equal to 3 for the whole thing to be equal, the whole thing to be true, and this is not true, which it's not, then there's no need to look at this second condition over here because you already know, the compiler already knows based on these rules, there's no way under the sun that this whole thing could be anything but false. Okay, because both of these have to be true. And if it looks at the first one and says, well, you know, there's no reason to look at this one because that's false, then it's not going to look at it. It's just called a short circuit operation, an optimization. Now, if I change this to 0, this is going to be true, but it doesn't know until it looks at it whether this one's going to be true or not. So it has to go and look at both of these in this case, just to make sure. Now, x does contain the value of 0 and y does contain the value of 3. So both of these are true, meaning this entire thing is evaluated as true. And just remember, this condition and, remember the little key word, this condition must be true for the whole thing to be true. Now let's look at an OR operation. Let's see. Okay. So it looks at this, and the rule for an OR, as you remember, is either this can be true or this condition can be true for the whole thing to be true. So only one of these need to be true for the whole thing to be true. All right, now let's look at this. If it looks at this leftmost condition, condition 1, and it sees that it's true, there's no need to look at this because you already know from the rules for an OR, only one of the other of these needs to be true for the whole thing to be true. Well, if that's true, then this whole thing evaluates as what? True. If this were false, however, it would have to go look at this second one to see that if it's true or not, okay? Because it doesn't know till it looks at it. So this one's false, so it has to go over here and look at this one. This one's true, so the rule for an OR is only one or both of these can be true. The whole thing is true. Then this whole thing evaluates as true because only one needs to be true, and y is equal to 3. All right, so it's kind of the opposite of an AND. All righty. Now you can model these using nested ifs, which we'll get into later. So you can avoid using those, but there's nothing wrong with using them to a limited degree. You don't want to mess up the readability here. So going back, let's look at 128, and if you do, you will see the truth table for an AND operator. The only way an AND can be true is for both subconditions to be true. Subcondition 1 and subcondition 2 on the left and the right. If one or the other is false, the whole thing is false, and these aren't evaluated because it already knows it's false looking at the subcondition 1 over there. For an OR, the only way it can be false is if both of the subconditions are false. So it's the opposite of an AND. You only need one to be true for the whole thing to be true. And an AND, you need both to be true for the whole thing to be true. Let's see. They give you the precedence numbers here on page 130. Again, it's sort of a summary of the operations. And I believe that's pretty much it. Now, you don't have to just compare against numbers. It can be Boolean values, strings, characters. Doesn't matter. Now, we will get into more on the selection structure. So I'm going to call myself done with this, and I'll go ahead and get to the Project 5 video as well.